We'll stop the transcription. Please keep yourself muted if you're not speaking. Thank you. Okay, so we're starting. First of all, welcome everybody. My name is Danai Pandelidi, and on behalf of ENOL, I want to welcome you for this online session on exploring large language models in action. And specifically, we have AI Lab from the City of Amsterdam with us, and Iva, who will present how they have been approaching the LLMs and how they have been implementing them through cases for the municipality of Amsterdam. And I just want to let you know that this event is co-organized through two projects. We have the Living in EU project, and this is part of the Education and Capacity Building Working Group. And we also have a Communicity that I believe most of you are familiar with. So as you have seen, this meeting is recorded. And this is because we want to upload the recording on CommuniLab for Communicity and the knowledge base of Living in EU project, because we believe that these use cases will be useful for others to explore and also to share with you after the session is over. Just for you to know, the Q&A session is not recorded. So I will be stopping the recording then, and you will be free to open your cameras as well. But Eva wants to have a more interactive session. So in case you want to not be visible while the recording is running, you're free to just write your questions in the chat. And there's no visibility for you online there. Otherwise, you can raise your hand and go ahead and ask. So going briefly through the agenda, I will be offering you an overview of the two projects and then handing over to Eva for the main presentation on the LLMs and how they have been implemented in the city of Amsterdam. And then we have the Q&A session, but as I said, it will be more interactive. I leave this up to Iva. Okay, so starting with the Living in EU project, this is a European initiative for cities, regions, and member states that they want to promote digital transformation within their areas of work. So the main target group is cities. And we have today almost 200 municipalities and regional authorities that have signed the declaration of the movement, as well as 190 supporters, which are other organizations that are not cities or regional authorities. So small enterprises, bigger companies, research institutions, universities, they can all join the movement, either as a signatory or as a supporter. And just to give you a better idea of how this is working now, there is the GoalEU project that is currently governing the movement, and we have the partners that you can see here, which are networks or associations that have members who are supporting this initiative. So we have Eurocities, ERIN, the CRESERM, we have OASC, and the European Network of Living Labs. And this initiative is also supported by the Commission and the European Committee of the Regions. So I will be briefly showing the assets of the Living in EU movement, which these are ready to use resources for cities and communities, for cities that want to deploy digital solutions. So there is the minimal interoperability mechanism, the MIMS. There are the AI procurement clauses, the Lordimas tool, which is an assessment for cities to understand where they are in the digital assessment ranking, and also the Living Lab approach. And I will not go into detail, but in case you're a city representative, we're always here to support you. And if you wish to use these assets or learn more about it, you can reach out to us, and we will guide you through the process and also connect you with the relevant parties. So part of the movement is to offer some relevant trainings through the working groups that you can see here. We have the Education and Capacity Building Working Group. And one of the activities that we have is the one that you are joining today. We have the Legal Working Group, the Financial Working Group, the Monitoring and Measuring, and the Technical Working Group. And for you to know, each of the working groups offers a series of meetings that can either be online or offline. And these offerings, they are co-created with them. So we have sessions where people, the members assessed their needs, and they share with us what we could offer to them. And based on that, we shape the annual plans of the working groups for 2025. And they will be published either by the end of this week or early next week. We're waiting for the approval by the European Commission, but stay tuned for more information coming soon. And this is just what we will do for the Education and Capacity Building Working Group. As I said, it's still under approval by the Commission, but we want to offer an event coming up on the 26th of February, which will be on how cities can navigate this digital shift and how to better identify how they can proceed internally to understand how they can upskill the workforce. There is a training on the memes. And we want to showcase their community pilot projects as well. So if this is interesting for you, we will be in touch. We also have an event on funding opportunities, again for authorities, a training on Cityverse, which is a collaboration with the ethics, and a basic AI training, as well as use cases for cities. And lastly, for Living in EU, we have the knowledge base, which is now live since November. And here you can find the material that is relevant to the objectives of the project. And you can find it in this website here. So at this point, I would like to invite you all to join the Living in EU movement. In case you're a city or regional authority, you can join as a signatory. And if you're a company, as many of you are today, you can support the movement by being a supporter. In case you're supporting already cities, as it happens in Communicity, I believe that this would be a nice network for you to join and useful. So now we'll briefly go through the Communicity project. As you know, Communicity is a Horizon Europe project, which aims to fund 100 technology-based solutions for cities through piloting. And these solutions have a clear objective of benefiting vulnerable groups of the communities, or marginalized groups, as we most commonly say for the project. And we have 12 partners from 6 countries joining the consortium of Communicity. And specifically, we have 3 partner cities, which are Amsterdam, Helsinki, and Porto cities. And these are also the ones that show the way for the rest of the cities that joined the rest of the pilots. And we're now on the 3rd and last round of pilots. And many of you are here today because you're part of the pilot team. So it's great to have you joining us. Now I want to briefly show you CommuniLab, which is the mutual space for learning for Communicity. And we have been adding here material that relates to capacity building. We have a knowledge repository and also a space for engagement and collaboration among the stakeholders of the project. And you can find it if you join Communicity, the main website of the project. You can find it on the tab here or in this website. So the capacity building space is a space where we host some frequently asked questions that are on general matters and how to pilot. There are some webinars and recordings from past online events. We have some multimedia, the videos that we're creating, articles and other relevant material. And we also have a tips and tricks page, which we have now added a guide on how to co-create, as well as how to design a living lab. We're looking forward to add more information there soon. Then we have the knowledge space, where you can find information about the approach that is followed in Communicity to achieve the objectives of the project. And this is the Communicity journey. We also have the catalog of tools, where we have added all the solutions that have been generated through the project. We have the manuals for open calls and piloting, which are very detailed guides on how to do this procedure of open calls and piloting. And we also have a page on methodologies, tools and toolkits, where you can find the co-creation approaches. There is a tech framework, and there is more material coming soon, as well as the deck of cards that has been prepared to help cities and tech providers to co-create with marginalized groups, as well as to use internally within their teams. And lastly, the resources. These are the deliverables that are public, and the scientific papers, as well as other material that we think that it might be useful for you. And lastly, we have this collaboration and engagement space, where you can find all the events we organize, the agenda. You also can find the relevant news from pilot teams. In case you're a pilot team, you can send us your news once you start piloting, and we can share it there on the page. There is this LinkedIn page that we created, and we want to have you engage there and share your experiences. If you need suggestions, if you're facing some troubles while piloting, this is a space for you to share. And we also have a suggestion box for receiving your feedback. From Community's perspective, we have 2 events coming up. There is the event on March on the memes, where we want also to involve the Community pilot projects, and also an assessment on Community Lab and how it can be further advanced to meet your needs, as well as to exploit after the end of the project. And this is just the QR code for Community Lab for you to access. And with this, I'm done, and I hand over to Iva for the main part of the presentation.
Yeah, thank you. Let me just screen share. Hi, everyone. I think I have to share full desktop. Everybody sees this, right? Yeah, yes. And everybody hears me well?
Yes.
I'm gonna need to screen share like this because I was just having some issues exporting the presentation. So you will have to see my whole screen, but the content is more important. So I'm Iva. I'm part of the AI lab of City of Amsterdam, as already mentioned. We are a central team in the innovation department that monitors emerging AI technology and tries to help our colleagues adopt it as soon as possible in a responsible way. So, for example, in the past, we've done a lot of projects researching what computer vision can mean for the city. We have a large data set of panorama images. So we wanted to see what can we see in the public space. Can we help, for example, with asset management? Then we moved on at some point to point cloud data, which allows us to more precisely localize things like street lamps and trees. And in the last 1 year, it's been actually a lot about language models and analyzing documents, a bit what's been entertaining the whole world. So that's what I'm gonna share with you today. our learnings from two specific use cases, and general thoughts on responsible use of language models from all of our experiments. So when the whole LLM hype started a year and a half ago, I believe, at the municipality, we got an overflow of questions like, oh, can we use GPT for this? Can we use GPT for that? But GPT is actually maybe not the best model we want to use. We started researching, okay, what models are actually there at all? And can we start making a choice about this? We knew that there's already a lot of research done on different models and a lot of overviews of available options. For example, I don't know if people here have seen this one, the opening up ChatGPT page, where people enumerate like different levels of openness of language models, because it's not just about the weight, it's also about data, about architecture, ideally peer-reviewed papers with more details that experts have looked at, etc., etc. So we thought, let's just pick a few of these models. This was our selection back then. Again, this is like a year and a half, maybe ago, research. And we wanted to see, can we find a compromise a little bit between openness of models and performance on Dutch, because a lot of these benchmarks in the world, they are done on English, and we just didn't know all of these models. Do they actually work well for Dutch? So what we did back then was a small study. We handpicked 30, 40 different prompts for municipal use cases and just compared all models. And we wanted to really start a conversation about and performance, what do we need in terms of performance for different tasks, but also about the development of the whole model. So some things like popped up like, okay, GPT is apparently in terms of performance great. However, the page I was just showing earlier, we know nothing about it. It's a very untransparent model. We know nothing about training data, about architecture, about environmental impact. There are models like Falcon that the 40B version, for example, performed pretty well on Dutch. However, there's also some missing details about, like, training code of the model is not available as far as I remember. And it's a very slow model, and slow is bad not only for user needs to wait long to receive a response, but it also means it's very resource intensive to use this model in production. There was the leader in terms of openness, Bloom's, for example. We figured out that Dutch has been explicitly excluded from the training data of this model. So we could not get it to work decently for whatever reason. We were hoping that maybe with some translation tricks we can do something, but we could not get coherent responses at all for Dutch. So that was very disappointing. And it just started at that time a lot of conversations internally for, hey, maybe we cannot pick one model to rule them all. Maybe we should look at specific use cases, but what else do we need to know about these models? And yeah, actually, I'm happy to say that now, finally, there will be a dedicated team put together that will dive more into this. But the biggest thing that people asked back then was, oh, and what about bias, and what about bias, and what about bias? Everybody knew that there's some bias in all of these models, like gender bias, bias related to religion or ethnical background of people, etc. But one study I found very interesting for the municipal context was, for example, this in the middle from TNO. What they did was to let different large language models fill in the kieskompas. For the Dutch people in the room, maybe they know the platform. Kieskompas is a Dutch system where you can answer a few questions like, shall we use green energy? Shall we invest more in social housing? What should we do with education? And then once you fill in your answers, you get some insights into, your answers highly correlate with the views of this party. and they're very far away from the views of that other party. And I was going to say what you see here, you maybe don't really see, but I'm going to elaborate. All the dots are the responses of GPT, Falcon, Llama. They've picked a few models. They've let these models fill in the KISS compass. And you see where in the space they're close to which parties. Essentially, most of these models end up having views closely similar to those of left progressive parties and quite far from the right parties, which is kind of expected because in the training processes of these models, you often have these bias mitigation strategies for like avoiding hate speech and ensuring gender equality and so on, which kind of naturally puts them in that corner. But it also means that all of these models are not partial. So they do have some political preferences in a way. And if you would like to use it, especially in a context like the municipal, where there are a lot of decision-making and policy-making applications, you might want to be very careful with like what kind of policies these models will be coming with, right? And another recent study that is also very interesting is, so these people basically provoked language models explicitly or implicitly in different setups to generate risky content. And they used another language model as a judge, and they measured how often the models refuse to generate risky content. So like the greener boxes, the more the model actually refused to generate bad stuff. And what we see is on the left are things like hate speech, illegal stuff, like really, really obviously unlawful, harmful content. And okay, many models do regularly refuse to generate such content, so they kind of reject the provocation. However, there's already a long way to go. Like on the right side, if you look at things like advice in regulated industries, political persuasion, automated decision making, things like that were not super explicitly taken into account usually in the training processes, all of these models fail to refuse it. So they basically, you provoke them and they just generate blah, 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 blah. So we have to be very, very careful with how we use these models and what for. And we did some practical experiments ourselves, and what we saw is that often all these biases, they're actually very hard to notice because it's not about single response. So single responses of models, they all look decent, like there's no like swear words, there's no explicit super explicit bias like comparing people explicitly. But if you do prompt them many times, which happens with large-scale applications, that's when things pop up. And for example, we prompted 100 times models with the same situations. And if you would prompt a model to respond to an email about a work conflict for a salary raise that was not given, for the male case, the model 1.5 times more uses the word unreliable, where for a female case, like when your boss was female, then it uses frustrating. So there's like some very clear difference of treatment between the two groups. Also, if you ask, okay, in a neighborly conflict where my neighbor, man or a woman, in Dutch this is different words, buurvrouw and buurman, if you ask what measure should I take if my neighbor is being too loud or we have some issue, if you ask one time, actually for every response you see decent stuff. It's like, go talk to the person if you cannot do anything, like maybe try to make a signal in the municipality, call the police. If things are very bad, maybe take juridical steps, like sue the person. And for a woman, it actually, if you prompt 100 times, it proposes the juridical steps twice more often than for men. So individually, every response looks fine, but when we use such models on a large scale, then these biases really pop up and they can really cause disbalance in society. And then we collected a lot of mitigation strategies at the time that we proposed to teams that were already using language models. And we separated them in 4. So the first step where you can interfere to make sure you reduce as much as possible bias is in the training of the model, in the data selection, the model architecture, how you do alignment with human preferences, etc., etc. The unfortunate thing is that with many pilots, and especially with people in the group here that are busy with pilots now, this is not something we can control because we don't train the models from scratch ourselves. What you can do though is to select a model for which you know how this training was done. And this means that you do need to have full details about the process. So you do have to select a model for which you do know what mitigation strategies they took. So that's kind of first advice. Then the next moment you can interfere is when you prompt these models. So how you, before things enter in a way or as they enter a model. You can try to moderate content, so check the input. Is this something I even want to process and respond to? Maybe you want to rephrase it to make sure that there's no bias caused by, for example, dialects, misspelled things, language differences, like the use of language of the user to have the same treatment. You can rephrase things. You can instruct the model explicitly to do something about it. There's actually also quite a lot of options there, and there's also options for output. So once you're generating output, you can generate maybe multiple answers and select one of them. You can monitor output over time to make sure things are not going bad because of semantic drift or something. You can fix things explicitly. You can check the output and say, oh, so certain words I'm not going to use. Or if you don't like the response, you can reprompt the model. Essentially quite a lot of options, but the way I see it, all of them assume that you have some concrete metric or a way to assess, like, is this biased or not? Do I want to do something about it or not? So our recommendation here is really to start with defining these metrics and refining like the guiding principles for what do we find acceptable or not, what do we want to measure or not, to be able to meaningfully optimize a system around that afterwards. And I think one of the most important parts is the design of the system and the whole process around it. So often these things are put on the shoulders of techies, assuming that, oh, fix the model, select a good model, do something with your black magic. But I think it's a lot about everything around it, about putting enough disclaimers in the UI to explain to people how this works, what they should use it about, what they should be careful with how they generally use the responses, whether you put it directly in use to a citizen or a user, or is there a human in between that would check it? Do you allow user feedback? So maybe you did everything great, but there's still something you missed, and you should let people have the option to like tell you, hey, this was harmful, this was not nice, I experienced it bad, fix it. So like give people the chance to give you feedback. And the cool thing about this is that all of these I think can be implemented at any stage. So often we hear, yeah, okay, but this is already in production, too late, we cannot fix the model. But I think it's never too late to pick up any of these design steps and rethink it and improve something. And that brings us actually all of these, they're general guidelines, ideas. However, they're which one exactly you pick, it's very use case specific. So I'm going to go into 2 use cases that we did and the general learnings from them. The first one is for a platform called Open Amsterdam. Open Amsterdam is a system where we publish any formal documents. In the Netherlands, there is this obligation, a law that says from certain types of documents like meeting, agendas, formal decisions, there's like 17 categories. All of them have to be made publicly available, and we are even proactively making publicly available more than that. So Open Amsterdam is a system where they dump all of these documents. And at the moment, it's a system with keyword-based search where nobody can actually find anything. Keyword-based search only in the titles, if I recall correctly, of the document. So not even in the content, because it's all sorts of like N-word documents and PDFs and WhatsApp screenshots and whatnot. So they didn't even bother. They just thought, let's search through the metadata and that's all. So it's very useless. And we thought, okay, how about we try to process these documents and let people ask questions about them in natural language? Because at the end, it's not about having all documents, it's about getting the insights out of them. And this is very obviously a very convenient retrieval augmented generation use case. I'm kind of assuming most people in the room are techies, but if somebody is not familiar with the technology, retrieval augmented generation is the technology that allows us, like in normal language model interaction, you have a prompt, you pass it to a model directly generates an answer. And with retrieval augmented generation, we have this first one step where we go to a knowledge base, we retrieve some documents, pieces of information, depends how you set it up. We take all of that information and we pass it to the model together with the question, and only then we generate an answer. So we thought, let's set this up. We just index in a pragmatic way documents from Open Amsterdam, and we see, can we answer questions? And to keep a very small pilot and to like start diving into, is this feasible? What are we going to run into? We thought, let's just select, I think we had 6 prompts, only 6 prompts, but they were super diverse. So some were very factual. Can you find this specific piece of information in a concrete document? And others were like very vague, requiring combining information from multiple documents, etc., etc. So we picked 6 different prompts, and we just got a part of Open Amsterdam. We didn't index everything because we also wanted to reduce environmental impact. So we could do a little pilot to learn what we want to learn without necessarily overcomplicating everything and indexing all the thousands of documents and processing all images. For example, we said, let's just skip images for the pilot. We're going to figure it out later. We just took 600 documents and they were like both useful for the prompt, but also misleading to test also the search functionality. And yeah, we set up a simple system, and we focused on the experiments with experts. We presented them with a few different responses generated by 2 retrieval setups to compare 2 retrieval models and to compare 2 language models, Mistral and GPT. Mistral was the one from the previous study that we did, which was smallest but working the nicest, had some issues for Dutch at first, but they were very easily fixable by nicer prompting. It was generally a very nice compromise, so we thought, let's just compare that one to GPT. And what we did, I think this first step was actually super useful. We asked domain experts from the department, can you generate those answers instead of a language model? And that was very eye-opening for them as well, because they came back and they were like, oh, I don't know, so how long should this answer be? And in how much detail should I go? And should it be simple? They didn't know what to expect from an answer themselves. So like, how are we supposed to optimize a system if they have no clue what an answer should actually look like? And it was also, we shared with them we helped them out to not need to search themselves. We shared with them a bunch of these like and useful and misleading documents. We were like, yeah, generate the answer. There's some documents that can help you. And they were like, oh, but I don't know, is this now a document that's formally legally like, how is it called in English? when it's a legally binding document, when it's been already voted in the city council, or is this just a vision? And is there a newer version? And they actually had no clue how to prioritize information and how to judge the trustfulness of information themselves. So this was the first step to see that, okay, this is not going to be easy, just because it's not easy also for experts. And then what we did afterwards was to then a bit bigger group for evaluators, give them the questions, give them the generated answers and the ground truth from the first step. And we asked them to evaluate the chunks which were retrieved at first, to see was the information at all retrieved properly, and then evaluate the answer. Was the answer compiled properly? And the overall insights were, from the whole project, pretty straightforward. The system was easy to implement, but there were some challenges with the documents. That was also obvious from the first step of the evaluators. What I found most interesting from the whole experiment was that experts actually had slight preference for Mistral. So this was a time when everybody was saying, no, there's no model better than GPT, we should use GPT for everything, but there was actually slight preference for Mistral, which was really nice for us and giving us ammunition to keep researching open source models. And another thing we do for all of our projects are these ethical leaflets. Ethical leaflets are based on the TADA values. These are values co-created with Amsterdam citizens a while ago. They're more related to digital solutions in general, not AI, but we've tailored it a little bit to AI ourselves. And what we do is we sit down in a very diverse group and we look at these 6 values: being inclusive, being controlled, having technology that's tailored to people, that's open and transparent, etc. And everybody enumerates risks and opportunities related to each of these categories. Afterwards, we summarize all the risks and opportunities to get some sort of a feeling for how well are we doing on every value, and where we feel like, okay, this value is at risk of being harmed. We try to come up with action points to improve over time, a bit like that. And from this specific project, what was very interesting was that at some point I took the, I don't have a visual of that, but we took the Raga architecture and we tried to map all risks and opportunities to the corresponding stages of the system. And what you could very clearly see was that in the retrieval part were all the opportunities, and in the generation part of the system were all the risks. But it was like very, very clearly separated. And that was actually our advice at the end to the corresponding department, to first focus on improving search, because substituting their keyword-based search with at least some semantic search, something nicer, it already gives more transparency, makes the documents more accessible, etc., etc. But you don't necessarily have to go all the way to then process the final 10 chunks and generate a response. Maybe for now we can let people read it themselves. And it was in the generation part that they were worried, for example, that now all these documents are publicly available, but they've been publicly available under the assumption that any people cannot be recognized without reasonable amount of effort, like the GDPR thinking. But they say, okay, these language models, they put reasonable amount of effort into a whole different light. So now people might be be able to be recognized. So what does all this mean for privacy and security, even though it's like open documents? And even if we retrieve good information, sometimes the way it's phrased, it's factually misleading, can be interpreted in many ways. Maybe it's not the way we want to communicate it, etc., etc. So it was tons and tons of concerns related to the generation part directly. So yeah, for the pilot people, if you can stay a step earlier, please consider doing that. And the other use case that we did was for a system called Meldingen. So Meldingen is a system in Amsterdam, or like signals in English, where you can type issues that you encounter in the public space, like the street lamp in front of my house is broken, or a bench, or there's trash on the street. Can you please do something about it? Can you fix it? Can you pick it up? And what's really not nice at the moment is that we have so many of these signals and not enough capacity to process them. But 20 to 30% of them, it's estimated that they're signals for which we're not going to do anything new. There's not going to be any follow-up action because the solution is already planned. For example, if there's garbage on the street, but we already know the garbage truck will come this afternoon, we're not going to do anything new, right? It's information we already know. It's just a matter of communicating it. Or sometimes, for example, we just cannot offer a solution. Fun fact, in Amsterdam, we don't mow grass anymore because it's better for biodiversity. So unless it's very dangerous, we're not going to do anything. And these people, 20-30% of the users, they need to wait for days, sometimes even weeks, to hear, oh, really sorry, but by the way, we're not going to do anything. Or, oh, there was garbage. We have picked it up a few weeks ago. It actually did happen to me, to report full paper container and to get 4 weeks later a reply, you reported a full paper container. We've cleaned it in between. So we thought, okay, can't we also all this information from internal systems that we have about policy, about routes of garbage trucks, about work that we have already planned in the city anyway, can we use it to provide information? Yeah, a bit like that. This is what people came to us with, like, people have a report, we have all the information, can you generate an answer? So this naturally sounds again like the retrieval augmented generation setup, right? With the only difference that before we had like one somewhat homogeneous knowledge base here, one data source, the documents from Open Amsterdam. And now it gets a little bit trickier because you have route schedules, you have the schedules of the street cleaning people, but you also have sometimes car permit information. If someone parked on the sidewalk, you have policy, you have many diverse things. So for this project, we thought, okay, let's go a step further. And this is what we call agentic retrieval augmented generation. So I can assume also many of the techies around are already familiar with this. But for the non-techies, big difference being that here in the middle, where before we had question, we go to some knowledge base and a language model generates an answer. Now we don't have one single step, one language model, but we have this whole agent. And this agent is essentially, in literature, agents are described as pieces of software which in some way can sense their environment. So agents can be, for example, robots that see what's in front of them, but it can be also traffic light agents that get structured information about how many cars are there on every side of the traffic light. So it's just something that can perceive external information and knows what's the current state of the world around it and can autonomously decide on the next action to take. So when it comes to large language models and these retrieval augmented generation setups, an agent is just something that is given tools, so not one knowledge base anymore with one retrieval, but multiple of them. And it can also be other tools like a calculator or a weather forecast or, I don't know, searching on Google, whatever. And this piece in the middle can decide on its own which action to take, which tool can I go to solve the task. In this retrieval augmented generation setup, it's prompt comes in, say a report about garbage on the street, so we can go search for available information. And in our specific use case, this is, we can go, for example, to the API with waste collection information, or we can go to the API which tells us for each building in Amsterdam who does it belong to, what kind of building it is, etc. We can go for policy to the Amsterdam.nl website. We can look up whether there are reports already made that are similar. We can pick up parking permit information, etc., etc. So yeah, basically one thing that does not at once retrieve information, generate, but decides somehow what information do I need, and then goes collects it autonomously, and then based on that generates a response. And it can choose to use many of these tools. How this actually works in practice is language model is then sort of kind of like the little brain of this agent, and we instruct it something like where we normally say, this is the prompt to generate a response. Now it's like a little bit of a longer thing where we explain, okay, you're a civil servant handling reports, and there's some communication guidelines that we explain to you. That's the report. And these are all your tools. We state their names and we describe what each tool does. And we also tell the model, hey, can you please use this little template to reason. And what the model does is it takes the whole description and then it thinks like, okay, so in this situation, I maybe have to use a tool I'm going to use. And here it generates this action input, or it generates the next tokens that models normally predict. They are the name of the tool it wants to use. We somehow use the tool as observation. It gets the response, and it can do this a few times, and then at the end, it can generate a final response. I'm going to say in a second why am I emphasizing this here with the action and action point for the techies, but it's essentially just a special way of prompting a language model to guide it into being able to use these tools. This is, by the way, how it works actually in reality. So we have a report. This is like actual output from the system that there is garbage on the next to a container in my street. It really does, like, thought is, okay, I need to gather information about waste collection. So first generated action is, I'm going to call this tool called get waste collection info. And as input, I'm going to use the address of the person. The observation part here, this is what comes back from the waste collection API. Then I don't remember why we've hidden this thought. Maybe for the reporting purposes it was too long, but it's probably something like, okay, now I know the truck will not come for 2 days. Let me see, are there already similar reports? And the report itself will be the input. And then as observation, we have what similar reports are there in the area. And then we have another thought saying, okay, I have gathered enough information. Seems like the waste collection is already scheduled for Monday or Tuesday or Thursday, and there are already a few reports which indicate that the issue is known and addressed. So I'm just going to tell the person to be like calm, we're on this, we know about this. A bit like that. It's like pretty straightforward setup, coming with a lot of issues. First one was, okay, what do we now do with the open language models? Initial implementation of this, for the techies, it was super straightforward with LangChain, which I personally don't really like as a library, but it was very straightforward. However, at some point we said, can we switch GPT underneath with another model? And that's where Hasso started, because everything was already optimized during my holidays with GPT. And when I came back, I realized that, okay, to swap in like retrospect a language model, all language models, they've been trained differently. So this reasoning template, it's different for all of them. Okay, easy peasy, you can change the reasoning template. You have to change a whole bunch of parameters, because like most models don't generate action input, but something else. So the library that parses the output to actually execute a tool does not recognize them. There's some hassle. But also the tool descriptions were not, they were optimized for GPT, not for another model. So we had to adjust that. And one thing after the other, it appeared that the system had gone already so large that we couldn't easily swap the models anymore to get any meaningful performance. So huge advice, if anybody is setting up something like this, especially from scratch, better come up with a model and optimize from scratch because retroactively swapping a model is not as straightforward as it might sound these days. And overall insights from the whole project were that, again, system easy to set up, but there were so many issues related to the language models, like, for example, because it's a language model that performs the reasoning, the usage of the tools gets very unpredictable and inconsistent. It calls them in different orders. Sometimes it calls something, sometimes not. So answers were really not consistent. At least once it collects information, the combining all the relevant pieces, that was going fine. And there were a lot of issues related to communication style. Because our communication department has like 7 golden rules of communication, we could not easily force the model to adhere to each one of them. And that brought a very interesting conversation about, but what do we expect from the communication of an artificial agent? Do we even want them to follow our own communication guidelines? Do they need to be empathetic? Do they need to communicate in the same way we do? Or we communicate in that way because we send responses a week later and we have to also do some damage management control there. But if people receive information on the spot and they know this is an automated system, maybe it is fine if they receive a very clear, cold, factual information. And actually this was also what the user research showed, that people prefer short, to the point, just give me the information, move on, don't give me additional details. We had, by the way, quite extensive user research about this. I can share the full report. I think it's already online, actually. I will show you the link. If anybody is interested, you can dive into all the details. And what we did there was also little bias experiments. Again, checking if you ask model 100 times, imagine you're a citizen from a certain neighborhood and you see young people singing and having fun outside. What emotion describes how you feel best? What's interesting to see is that, so if you come from New West, one neighborhood of Amsterdam, you would be happy and cheerful. You don't really care that there are people outside. Another neighborhood, you're mostly indifferent, a little bit annoyed, but sometimes still very happy and cheerful, mixed emotions. And if you come from the center of Amsterdam that's full of tourists, you will be 100% annoyed. And it kind of makes sense, of course, that people in different neighborhoods generally have different attitudes, but I think this shows that if you want a language model to reply empathetically, like empathetic means that it understands the emotion of the person. So people in different neighborhoods will get different response, differently empathetic response, because of this underlying assumption of how they might feel about the situation. So I think it's nice to keep in mind that with these agents, there will always be different treatment of people, and you have to think well when implementing them, in what ways will people get different treatment and is it desirable? And another example was for the full system. We checked, so if there are screaming youngsters on a square playing with fireworks, in one part of the city, the final advice is it may be helpful to communicate with young people, reach to available support options, point them to that. So like sort of peaceful conflict resolution. And then in another area of the city, it's, it might be helpful to contact local authorities and the police to intervene, so a little bit more escalating things. Again, if you have a system like that put in production in a full city, over time you really will get these different different advices that will lead to structurally different treatment of people and situations in the whole city. And for this project, we also did the ethical leaflet. I think, especially from the community project, there's quite a few that are chatbot related. So I will be happy to share the full insights with people if you're interested in. But overall, very mixed feelings. So in terms of opportunities, this technology really makes it easier to talk to citizens and makes it more inclusive in the sense that people can just talk to us in natural language, in any language they like. It could make communication more personal because we can really prompt model to, for example, generate responses on different level of complexity to tailor to like well-educated people versus low literacy users. It could, in theory, be more objective because we easily pull information from policy databases and so on. And can be more transparent because at the moment people just don't have the information we have. So like providing them with sources and with information on the spot can make us more transparent. Can also free up time for our colleagues to have more human solutions and make even their own job more enjoyable. But all of this also has the other side of the coin, right? Like it can be more inclusive to some people, but some people might find it hard a digital system to use. It can make our contact with people less human. Language models are not very transparent, so not everyone will understand how it works, why certain response was generated. And biggest concern, they have huge environmental impact. I'll skip the action points because I see we are pretty short on time. And the last bit of I think I wanted to share was this concern with the environmental impact, because it's also something that pops up in all of our ethical leaflet sessions. The technology has huge impact. For the first project I showed you, the standard rack solution, back then we thought, okay, quick and pragmatic, let's just quickly log some runtimes to try to understand for at least the pilot what emissions did we generate. But this was a lot of hassle. It was really nice to see that, for example, in the retrieval part, things were pretty static. It's a like one-time thing that happens and it's not very intense calculations, but the generation of responses, if a system is used more often, this is the part that's actually very heavy. So we got some insights from there and we thought, okay, for next project, we're gonna do this differently. We're gonna use code carbon and we're gonna calculate for everything we do on the spot climate impact. And there we had the issue that we couldn't easily substitute the language model. And if you use models like GPT and the standard API, you have no clue. All the climate impact, it actually happens behind the API. So you have no clue what is happening there, which was very, very sad moment. Big advice, always try to integrate open source models from the beginning to be able to generate this impact, to calculate this impact. And at least if you do go for GPT, like in our case, what we did try to do is at least enumerate the things that keep in mind. This all makes more impact, like we cannot quantify how much, but for example, number of calls to LLM, agentic setups trigger many, many calls to a language model. We had some scenarios where we had 10 language model calls per single request, per single signal to process. How many tools you have, because the model can decide to use almost all of them. How big your prompt is, the prompt length impacts environmental impact. If you have more guidelines and so on that go with each and every request. The response length, of course, you generate tokens, everything is per token. So there are many things that you can think how to make it smaller, even if you cannot quantify exactly what's on the back. And final thought, especially for the Amsterdam community pilots, all of these considerations, ethical considerations, climate impact, etc., if things go eventually in production for the municipality, we have this whole ginormous generative AI process, and in later stages, this will be looked at. So I know for a small pilot, it's always hard to think of everything, but keep in mind that It will need to happen at some point, so thinking about it from early on really helps to avoid like bottlenecks later. And all of these reports are, by the way, on open research and GitHub and a website we don't maintain super much anymore, but there's information. So if you're interested, please go check the full reports or contact me for more info.
Thank you very much, Iva. I think this was a very great presentation on the holistic approach of Amsterdam. I will stop the recording now, and in case there are any questions, please go ahead.